human beings or animals can perform work and therefore they possess energy. And we always use this term energy in our day-to-day life. Like we sometimes say that uh, we feel low on energy, I don't have energy to do this work, this type of thing. In physics, energy is a term that defines another thing. What is energy? The formal definition of energy is energy of a body is the capacity or ability to do work. So, what is this? It is the capacity or ability to do work. And how we measure energy? It is said that it is measured by the amount of work done the body can do. So, from the formal definition, we can say that work and energy has a relation. Work and energy has a relation with energy. So why there is a work, there must be possess an energy. Why this we possess some energy, there must be we do some work. This is the concept of energy and work. We know the unit of energy is joule, and therefore we know the unit of work is joule, so therefore the unit of energy also joule. The unit of energy, the unit unit of energy is also key joule, is also joule. So this is we have to remember about energy. In our everyday life, various facilities and comforts we enjoy come from the use of various forms of energy. So there are various forms of energy we use. So there are some classification of energy. There are some classifications of energy. Classification of energy. We will discuss some types of energy. Like one is mechanical energy. Mechanical energy. The second one is heat energy. The energy possessed due to heat. The third one is sound energy. The fourth one is light energy. The fifth one is magnetic energy. The sixth one is electrical energy. The another one is chemical energy. The another one is atomic energy. And another form is solar energy. So there is some classifications of energy, but in this chapter we will only discuss about this mechanical energy. And this mechanical energy is divided into two parts. One is kinetic energy, and another one is potential energy. And we will discuss these two energy in this chapter. Okay, so this is the formal definitions of energy, and we know the unit of energy is joule. So now coming to the next part, what is kinetic energy? The formal definition of kinetic energy: the energy possessed by an object by virtue of its motion is called kinetic energy. That means when a work done by motion, then they possess a kinetic energy. So when a body is moving, it possesses a kinetic energy. So one example of kinetic energy is, suppose a bullet fired from a gun. A bullet fired from a gun can make a hole on a wall due to its kinetic energy. Suppose this is a gun. We fired a bullet it go, and this is our wall, and it makes a hole in that wall. Why this hole is happened? Because of this bullet possesses a kinetic energy, and this energy helps this bullet to make a hole on this wall. So this is an example of kinetic energy. So now we have to derive the formula of kinetic energy. So we have to derive some formula, the derivation. Suppose this is an object A. This is an object which has mass m, and at this A point, it has a it has a velocity v naught equals to 0, and we've applied a force. We applied a force F. At that point, and it moves at that path and and come rest at point B, where its final velocity Vf equals to 0. Where its final velocity Vf equals to 0. When we possess a force F, it moves with the velocity of V. So this is our first of all, this is the concept. We have to find out uh, the energy possessed due to this force. So we know what is energy. Energy is work done. The energy is the capacity or ability to do work. So if I want to find out the kinetic energy, I'll only find out the work done for this force F, and we know the formula of work is F into S. Here we know for F is m into mass into acceleration. Now we have to find out the distance S, the distance it travels. So we know there is a formula we learn in our linear motion chapter, which is S is equals to not this, which is V F square equals to V naught square plus 2as. Here our Vf is 0 and our V naught is this V, because we possess a force F, we possess a velocity V for this force F. This is not our initial velocity, because we didn't consider this concept. Okay, so our initial velocity is V. So instead of Vf we will use 0, instead of V naught we will use V square. And as it it has a declaration, like the accelerate doesn't accelerate, it declare it. So we will use minus of a, because the acceleration is negative, it decreases. So we will use minus of 2as. For that we will find out s equals to v square by twice a. So if we put this value there, we'll get ma into v square by twice a. So if we cutting down the a and a, we'll find out the kinetic energy equals to half of m v square. This is a formula to finding out kinetic energy. So we have to remember this formula. So we derive the formula for kinetic energy. Now coming to the next part, this part is known as work-energy theorem. This is a very important theorem. So what is this theorem says? This theorem says that the increase of kinetic energy of an object is equal to the work done by the applied force. Again, we have to draw a concept. So this is an object which has at point A, which is a velocity of, which is the mass of m, and we applied some force F in at that object, and this object move in that path. This object move in this path, and we take a point B. This object is moving with an acceleration of a due to the force F. It is a initial velocity of v naught, and it is at point B, it is a velocity of v, final velocity of v. So what is work energy theorem? We have to prove this theorem. So this theorem says that the increase of kinetic energy of an object is equal to the. So here we say the increase of kinetic energy of an object. So how we can find out the increase of kinetic energy? So if we have to find out the increase of kinetic energy, we have to substitute final kinetic energy to initial kinetic energy. Then we will find out the increase of kinetic energy, and we have to this increase of kinetic energy is equal to the work done by the applied force. So work done by the applied force. So this difference between initial final energy is equal to the work done by the applied force or the work. So we have to find out this equation. Let's go to the proof so you can understand it briefly. So coming to the proof. So proof is, we know work W equals to F into S. We know this is the formal definition of work. And for F we can write Ma. For F we can write Ma. And for S we can write, we know the formula of S is, S equals to not S, V square equals to V naught square plus 2A S, or we can write V square minus V naught square by twice A S equals to S. So instead of S we will write this thing. So how our equations look like? Our equation now will look like Ma into V square minus V naught square by twice A. So if I cutting down this two accelerated variable, then we'll get half of M V square minus V naught square. So W equals to, we'll get half of M V square minus half of M V naught square. Half of M V naught square. So what is this? This is the final velocity. And what is this? This is the initial velocity. And this difference is known as increase of kinetic energy. So this whole term is known as increase of kinetic energy. So we can write increase of kinetic energy, and which is equals to what? Which is equals to what? Which is equals to what? And how we can find out this work done by this force F, this force F. So this is the theorem of work energy theorem. We just prove this theorem, work energy theorem. So this is the whole proof of work energy theorem. In this work energy theorem, we have to remember only this part. The work equals to final kinetic energy minus initial kinetic energy. This is the part we have to remember, because this concept is used to prove many problems in our physics theory. So we have to remember this theory especially, this theorem especially. So that's all for today's video. In our next lecture, we will discuss potential energy and different kinds of different example of potential energy. Hope you like this video. Do subscribe to our channel. Thank you.